All right.
So, who's logged on to web study? Let's try that. Who's logged on to web study this semester for this class? Okay, who's not? Okay, so after today, I would strongly suggest that you start that process. We'll lecture all of today's module number 1 today. And I'm gonna, for the benefit of you guys and for the benefit of the online students, I'm gonna lecture directly from web study today. So you log in, if you go to the class, your class, which is section 1510. Oh yes. Go to your class. Here's timeline, go to your timeline. Oh, too much. All these settings. See, these computers auto reset every night. So all these settings that I'm clicking on, I'll have to do it next time. Some of you have, see homework has been done. All right. So if you go right here, you'll notice that web class, that's why they're doing homework. Timeline. If you notice right here, it says syllabus file, syllabus outline spring 2015. Okay? That's the syllabus that I handed out to you guys. I updated it, I accidentally had the fall syllabus on there. Just something I wanted to mention. We went through this in extensive detail last time. But if you notice on here, it has exams on here. Okay? This is the exams I was talking about where I could have an exam in class if I wanted to. Right? So my recommendations are, before you show up to class on the 27th, you do all your homework for chapters 1 through 5. Before you show to class on February 3rd, you do all your homework for 6, 7, 8, 9. Before you show up on the 10th, probably should do all your homework for 10, 11, 12, and 13. This will do two things. It will keep you on track, and it will also make it so if I do decide to do an exam at that time in class to test how you're really doing in the class, you'll be ready and prepared. Okay? It'll be a breeze for you. You'll get a good grade. So, I put those on there to help keep you in track. So on this day, on January 27th, you should probably do exam 1 before you come to class. Okay? And not so on and so on. Does that make sense to everybody? Something I wanted to make sure that you guys understood. So you'll see that stuff on there. You're like, oh, but we don't have to really not do until the 13th of March. Well, honestly, that's really what it is due, but it will benefit you greatly to have everything done prior to that date so you don't get zeros and you'll be prepared for the in-class exam if we have it. Okay. So, another thing to remember I have on here, I've had a lot of emails. When's the due dates? No, I don't get it. So if you go down here, I don't have any calendar start or due dates. Because the way I do it is the module is available to you for a certain time frame. So that's when it opens, and this when it closes. That's the due date. So everything has, it's on the top, it shows on yours. If I flip it to student view, I got it. So this is what you guys see when you log in. Right? Start date. Okay, so everything is due by midnight or 11:59 p.m. for spring break. That way I can enjoy spring break. And you guys can too, so you don't have to do homework during spring break. Don't have anything to do during spring break. And nothing open for this class. So you guys should actually enjoy your spring break. Okay? Alright. Did that answer your questions? Yes. So, also if you you've logged on the website, you've seen that there's chapters, presentations 1 through 3 and 4 through 5. These are previous instructors, and sometimes I'll lecture from them, but most of the time, if I say Taz is PowerPoint's used in class, that's when I'm going to be lecturing from the class. Okay. All right, just make sure that you understand you get 2 attempts to do your assignments. So if you bought one for practice for a better grade, you can redo it. So, all right. Yes.
When you redo the assignment, does it take the grade the second time or just the better grade out of it too?
I said it so it takes the better grade. Unless you want me to put it the second time only.
No, that's okay.
You should have put unit Roman numeral on the chapter.
That would be way better, for more applicable to the chapter for sure. Okay. So, Roman numerals. Real quick before I get started. We are going through 5 chapters today. Most of this should be reviewed, okay? So, with that being said, if these chapters are really hard for you after today, try the assignments, try the practice. If you still don't get it after the assignments and the exams, come see me, because I'm doing HCE116, and we go a little bit slower. We go chapters 1 through 16 for the whole semester instead of 1 through 24 like we're doing here. So we go just a little bit slower to cover some of those concepts, and we do less chapters in a day. Now, as we get to more complicated chapters, you'll see on the syllabus, we don't do as much new information during the day. So part of these are clumped together because a lot of this should be review material, okay? So whether it be from high school or chemistry or whatever we're doing right now, okay? So Roman numerals. Roman numerals, we see them on timepieces, right? What sporting event right now is coming up? It has Roman numerals. The Super Bowl, right? That's in Roman numerals, okay? So, you'll see them in random places, and that's where we use letters as numbers, okay? There's Roman numerals, and then there's Arabic numbers. You guys didn't know you were learning Arabic today, did you? I'm just messing with you. The Arabic system is just the numbers that we're used to. That's what we use every day. Numbers are numbers, not letters, right? You can see them in fractions, decimals, and other things that use these numerals, right? That's what we're used to. Roman numerals use letters to present value. So the most common ones are I, V, and X. Some other ones that you might see are what are they? L, C, D, and M. Okay, those are all in your book on a table that looks like this. Okay? So just remember, this is in your book, so if you can't see it up there, you can follow along. Just remember when you're writing down Roman numerals that you never write down 4 of the same numeral. Okay? So, case in point, number 4 there, we'll see right there in the yellow. 4 is IV, not 4 I's. Okay, remember I stands for 1, V stands for 5, and X stands for 10. That's what we see most commonly. So, here's some of the rules of Roman numerals. When a Roman numeral of lesser value is placed after one of equal value, the numerals are added. Okay? So if I have a Roman numeral of I, but with the Roman numeral of I, what is my count? 2. Right. So, more complicated here, the example, we have XXV, okay? So this is equal to this one, and then this one is less than this one. So they can all be added, right? So X plus V, 10 plus 10 plus 5 is basic Roman numeral rules. Now, if you have a Roman numeral of lesser value that is placed before one of greater value, then you subtract from it. Okay, so the example up there, we have ix. So I is equal to 1, right? X is equal to 10. So if you have I, which is 1 before 10, lesser value, you subtract 1 from 10. So 10 minus 1 is equal to 9. Here's another one. We have xxiv. So remember that this before rule supersedes the after rule. So we have x, so that's 10, plus x, which is 10, and then we have an I here. Well, it's lesser than this one that it came after, right? But since this before rule supersedes the after rule, I is subtracted from b. This becomes their own separate number. Okay? So x plus x is 10 plus 10 plus 4, which is the 5 minus 1, is 24. Okay? Just remember these rules. We'll have some homework. Most of the Roman numeral homework will be quick boxes or multiple choice, so you really have to show your work. Okay? So let's do a couple on the board really quick. Because we have 10 plus 4, right? Put the parentheses on it only to show that it's separate. The parentheses aren't included in the math per se. I have that question every time. Why are you putting parentheses on it? Just to show that it's a separate number, okay? All right, what's another one? 29, why is it 29? Okay. That making sense to everybody? So how would I write this one? Okay. Why would I write this?
We don't feed anything more than
Right? Can't write 49 like that. So that's why. Okay? Too many X's. Okay. Any questions about Roman numerals so far? Okay. So we usually crank through lecture pretty quick in this class and do examples as we go. But most of the time we get out a little bit early. With that being said, I am still 100% yours because we're in the classroom until 11 o'clock. Okay? I mean, sorry, that's my work. Let me rephrase that. Till 3 o'clock. Okay? So if you want to stay after and get help, I'll hang out here in the classroom. I'll do things to make sure that you guys understand and succeed in the class. Okay? So always ask for questions, but if you're the shy type, it's like, oh my God, I'm in front of everybody. That's fine. Just make sure you come see me afterwards so we can make sure you understand. Okay? Fractions. So fractions are part of the whole number. Okay? So the number on top is part of the whole that's on bottom. So 1/2 is one part of the two-part whole, right? You have a numerator and a denominator. Numerator's on top, denominator's on the bottom. So if I was to look at this right here, this piece of pie, pie sounds easy right now. So if I was looking at this pie, how many, yes. Oh yeah, I forgot. I was doing work on the board, and my online people are probably gonna thank me for that too. All right, so how many parts of the whole are not shaded? 1/6 of the whole, right? How do I tell which is a greater, which is a larger piece of the pie? 1/32 or 1/6? What's the larger piece of the pie? 1/6, right? Because I'm dividing that whole by 32 pieces, right? If I had 1/32. So if I had a candy bar, I said, you want 1/2 of it? Or you want 1/8 of it? Which one would you want? Half, because that's the bigger piece, right? Unless it depends on the candy bar. If it's a candy bar you didn't like, you might take the 1/8 because it's smaller. But for most people that like candy bars, you would select the larger portion, right? So just remember that if it has a larger number on the bottom, that means that it's going to be greater than the one with, if it has a smaller number on the bottom, it's going to be greater than the one that has a larger number on the bottom. So, proper fraction, let's talk about fraction types. Numerator is less than the denominator, and the fraction has a value of less than 1, okay? So, 1/2 and 3/4, okay? Those are both proper fractions. Numerator has a number that is less than the denominator, okay? And this is less than 1. 1/2 is less than 1, right? 3/4 is still less than 1. Just remember that. Improper fraction. That is where your numerator is greater than your denominator. Just remember that that means that the value will be greater than 1. You can still get a lot of homework where people will do all this math and have an improper fraction and then still have the number less than 1, okay, when they do all the math out. So just remember, if you have a greater number on the top than the bottom, that number is greater than 1, okay? An improper fraction can be changed to a mixed number or a whole number by dividing the numerator by the denominator, okay? So if I have 6/5, I take 6 divided by 5, which is 1. Okay, if I did the long division out, then I would have a remainder of 1. So that would be 1 1/5, right? 10/8. If I take 10 divided by 8, that's 1, right? Minus the 8 gives me 2, a remainder of 2, so that's 1 2/8. This should be some elementary math revisited. And then 2/8 can be further reduced to 1 1/4. That being said, on your web study homework, the answers I want to see are mixed numbers with reduced answers. Okay, so I don't want to see 30-second 30ths, even though that's an answer on one of them in web study, on multiple choice. Make sure you just click the right answer. Okay, but when you're actually doing things in the dialog box underneath the question, I want it in the furthest reduced form, okay? So no improper, no 10/8, I want to see 1 1/4, okay? So mixed fractions is the whole number, we just talked about that, mixed with a fraction, okay? And you can change a mixed number into a improper fraction, which you might have to do if we are doing multiplication or adding, where you have to do the least common denominator. So, example on the board here is 5 1/8, okay? All I have to do is take 8 times 5 plus 1. That'll give me 41/8. Or you can do like this, 5 times 8 plus 1. But I just do it in that C fashion, okay? So that way, 8 times 5 is 40 plus 1 is 41. That's the easiest way to do it, okay? to adding, you have to make sure that you have the least common denominator. So if you do something like this, and I set it out, and it looks nice and easy, and all these are sixes on the bottom, guess what? You can do the math. 1 plus 3 plus 4 is 8/6. Okay? For Mr. Brinkerhoff here, on your web study though, is 8/6 the right answer? No, it's on the way to the right answer. What does it need to be reduced to?
1 and 1/3.
1 and 1/3, right? 6 goes into 8 one time, leaving 2 6 left, which is 2 6s reduced to 1/3, okay? If you have a different denominator, then you need to change the fraction to have an equivalent denominator. So that example is so awesome that I'm gonna do it on the board real quick. So it shows 1/4 plus 1/3 equals 7/12, right? So how did we get there? These have to be the same, right? So we already know that that is the common denominator is 12. So what do I need to multiply this one by? 3. So if I multiply the bottom by 3, what do I need to multiply the top by? 3. 3 times what?
4.
4, right? So if I did it to the bottom, I need to do it to the top. Okay? So now I have 3/12 plus 4/12. Then we can add 3 and 4 equals 7/12. Right? Did they close the door on me? Or somebody come in? Oh, somebody belled. Okay, just making sure. Oh man, I'm not knowing what your guy. So, just remember those rules. Just also, when you multiply the top and the bottom by the same number, all you're doing is changing numbers, you're not changing value. Okay? So if I multiply the top and bottom by the same number, I am changing numbers, but I am not changing value. When I'm reducing, if I'm dividing by the top and the bottom by the same number, I am not changing values, I am just changing the numbers. So 2 6, I divide the top and the bottom by 2, and it equals 1/3, right? They're the same value, just different numbers. So let's say if I give that to you and I say, show your work, I want you to show your work on that. Here's your dialog box. Right? So all you would have to put in there is write it how you would write it. Seem easy enough so you can get full credit? So chapters 1 through 5, if you can't figure out this concept, I'll let it slide a little bit. I'll still give you credit. After this first module though, when you get used to typing in all your work on the dialog box, I will make sure that it has credit where it'll be, has work where it'll have half credit for the right answer. Okay. That way, if you keep doing it wrong and you show your work, I can show you what step you're missing or messing up on. If you just have the wrong answer, then I can't help you. So make sure that you let me help you. And I got the light. Okay. Okay, when we're multiplying, we just multiply straight across, right? So we have 3/4 times 2/5 here on the projector. So 3 times 2 is 6. Then you multiply the bottom straight across. 4 times 5 is 20. Obviously that's the right answer, but not all the way right, because we want to reduce it for your web study answers. So 3/10 would be our reduced amount, okay? If we divided the top and the bottom both by the same number of 2. So if you want, you can reduce to the lowest terms, or you can even do the math. That way you don't get these crazy big numbers. But you still need to make sure that after you do the math, that you still reduce to the lowest terms, okay? dividing. You have 3/4 divided by 2/3 here. All we do is take that second number and make sure you remember it's only the second number, that you never flip the first one. It's only the second number that you'll flip, and then you do multiplication straight across. So we have 3/4 times 2/3. We just flipped those second numbers, so that way it's 3/2 now. So 3 times 3 and 4 times 2 is 9/8. But is that the whole right answer? No. So make sure that you take that improper fraction of 9/8 and make it into 1 1/8. Okay, this is just so you guys get full credit. Any questions on fractions? No? Moving on then, make sure you ask questions if you have some. Chapter 3. Okay. Decimals are very important, okay? We use them the most out of all the numbers in the healthcare field for dosages and other measurements like weights, mLs per hour, everything like that will have some sort of decimal place in it. So understanding where those decimal places move to make different values is very important and crucial to your success as a healthcare provider and your patient safety, okay? So decimal points are one of the major sources of medication errors. So like, case in point, we have digoxin here, 0.125 milligrams, okay? Or 125 micrograms. If I move that decimal place anywhere, it changes the dose significantly. So if I move it to the right, it would make it 1.25 milligrams, which would be 10 times the dose. Digoxin at 10 times the dose is cause digoxin toxicity and could kill your patient. Right? Coreg, 3.125 milligrams. I move that to the right, and that makes it 31.25 milligrams. Okay. I move it to the left, and it makes 0.3125 milligrams, right? Too much to the right can make the patient's heart rate slow down to 0 and cause them to have really low blood pressure. Too much to the left, this Coreg is a medication for congestive heart failure, will make it where their heart doesn't pump as well. So you want to make sure that you dose medications correctly. So decimal by definition is a fraction with a denominator that's a multiple of 10. So the decimal is used to indicate that place value. So something I would write on the board, like 3/10, 3/10. If I put 0.3, that is the same as 3/10, because that first decimal place is the tenths place, and I have 3 of them. So 3/10, okay? 18/100 is 18/100ths, right, or 1800ths. So I can write that as 0.18, because the second decimal place after the decimal is the hundredths, okay? So 1800ths. Make sure, if you notice here, it says each decimal expression with a value less than 1 is preceded by a leading 0 to emphasize the presence of a decimal. So I do that so that you guys can see, because what if I wrote this on the board as 0.18? No 0. Okay? It's a script. I wrote it as a script, and my pen wasn't working that great that day, and you can't see that point. So now I have 18 of something instead of having 0.18 of something, right? What if I had this though? And I didn't see the decimal point. Well, I know that since I have a leading 0, something's quite not right here. So then I know to question that, hey, is there a decimal there? Oh yeah. Scribble it in for you while you write the order. Okay? So make sure that you put leading 0s on everything that doesn't have a whole number in front. No 0.3. That is another thing that if you do it, you'll just get half credit for it. So if you put the answer as 0.3, if you put the answer as 0.18 without leading 0, although the right answer, you will get half credit. And you're thinking, man, that guy's pretty stiff. Or other words were used about me last semester, but that's okay. But I I do that because I want you guys to be safe, okay? Habit makes, practice makes permanent, so you have to have a perfect practice, because this practice doesn't make perfect, because if you practice it wrong all the time, you're gonna be wrong all the time. So make sure you have perfect practice. So decimal points, this is also in your book, so you can take a look at it. And this just shows the place values. Here's the decimal right here in the center underneath that arrow. We have tenths, hundredths, thousandths, 10,000ths, and 100,000ths on the right. On the left, the whole numbers, we have ones, tens, hundreds, thousands, 10,000s, and 100,000s, okay? Just notice that on the right, there's no once place, right? There's just goes right into the tenths, and then make sure that you realize that if it has a TH behind it, that means it's on the right side of the decimal. You notice these do not have any THs at the end, okay? So when you're reading it, you read the whole number first, then you will read the decimal point as an and then you read the decimal fraction as a fraction. So 8.3, and if you're talking to me, I'm not going to correct you if you say 8.3. But for book purposes and writing it out, we'll see, this will help you later, and we'll solve some of the homework. 8.3 would be 8 3/10. 4.06 would be 4 600ths. And 0.5 would be 5/10. Those are how you would say the decimal fraction. When you're getting an order on the phone, just remember that you read it back to them. So if they give you 0.5, you read it back to them. Did you say 0.5? Okay, make sure you say 0.5 or because one time we had a patient, they called in, the doctor made an order over the phone, and the normal dose for this sedation is 0.01 to 0.1. Well, he can be hard to understand sometimes, and the order was written 0.1 to 1. Okay, so thank goodness this patient was on a ventilator. Otherwise, they would have stopped breathing otherwise. But that was 10 times the dose. Was it really causing any harm to the patient? No, they were sedated on the ventilator. They just were really sleepy, extra sleepy, which is fine. But we had to do all the right and all the stuff because it was a med error, and we administered that med based on the order because we didn't read it back appropriately. So make sure that you, when you're reading, taking orders with the phone, which is very common in emergencies, or if you're in a situation where you're taking a verbal order, you always say it back to them. Also, when you're charting that as healthcare providers, you say verify with readback or with readback. That way, like order received, verify with readback. That way that you can show like, yeah, not only did he tell me and I took the order, but I said, are you sure about that? And he told me again, yes, that's the right. So legally that helps you guys out as healthcare providers. Doesn't make you feel better if you do a med error, but it makes it legally so the person that gave you the order is in bigger trouble than you. So when you're writing those decimals, if there is no whole number, then you will write a 0 for that leading 0 that we were talking about. But you write the whole number first, and then the decimal point, and then whatever the fraction of the number is. So if I said, hey, we're going to give 7 5/10 of this, then you would write down 7.5, right? 125 thousandths, so 0.125. Just remember, in chemistry, they talk about having trailing zeros so you can have the appropriate number of significant figures, right? Not in medication math. So I don't care about sig figs. I care about safe patient medication administration. So if you have an answer of 0.1250 after you do the math, then you drop the 0. The leading 0 and the trailing zeros do not change the value, but if you make a legible error and it's transcribed incorrectly, then a 0 in the wrong place can mean a big difference for the patient, right? So here's the example. 0.7 is the same as 0.7, but if I erase this decimal, that goes from 7 to 0.7, which would make you think, hey, there must be a decimal point there. 12.6250 is the same as 12.625, but if I mess up this decimal point, that's way lesser of a dose, right? Because here's case in point, 30.0 can be easily misinterpreted as 300, which is 10 times the dose. What if I had 0.1250, and I didn't have my leading zero, and I had a trailing zero, and I accidentally erased my my decimal place. So that went from 0.125 to 1,250. So, no big deal on a piece of paper, but kind of a big deal when you're telling patients, parents, that you accidentally OD'd their kid. Kind of understand? Don't want to be negative, but I kind of want to make sure you understand the importance of that. And you guys will do one of the, I think it's the next chapter, next module, you guys will do a forum. You'll read about a nurse who gave a pediatric patient 10 times the dose and the patient was dying, how it really affected their life. So, just make sure you understand that. So I'm not here to freak you out. Nursing is great though. Okay? Like, oh my gosh, but I want responsibility. So, we just talked about that. Zeros, depending on where they are, can change the value dramatically. So make sure that you are very careful with your zeros and your decimal points. Okay. So sometimes you'll do math. There's a popular medication that we give. It's called Levofed. Levofed is given to help patients in septic shock so their blood pressure comes up. Okay, so that way they don't die. So we give it all the time. So based on the concentration we mix, a lot of the times when you do the math comes out to 18.75 mLs per hour. Okay? My pumps that we use in the ICU only will only go out to the 10th. Okay, so can I plug in 18.75? No, I have to change that dose so that my pump can run. So then I would need to round to get the right answer, so my pump can be used. So if the numbers in the hundreds place is 5 or greater, if I was going to round to the 10, then I would round up. So here's our example, 4.15. Okay, so I have 4.15 mLs per hour that I need to plug into my pump that only takes it to the tenths. So what am I going to put in? So 1 is the tenths places where we're wanting to round to. So I would look at the next number, which is 5. Is that greater than or equal to 5? Yes. Good answer. So I would then round up the tenths to one more, so 4.2. If the number in the hundreds place is less than 5, then we would just leave that tenths place the same. So 4.14, okay? We want to round to the first decimal place, okay? So we look at the second, which is 4, which is not greater than or equal to 5. So we would just keep it at 4.1. Okay, does that make sense? It makes sense now, but for some reason, I'll put on there round to the tenths, and I'll get it rounded to the hundreds. I'll put round to the hundreds, and I'll get it to the tenths. So make sure you understand what decimal place you're rounding to. So if I want to make a decimal place from a fraction, all I have to do is take the top number and divide it by the bottom number. Okay? So here's some long division here. 2 divided by 5, so 2 divided by 5. 5 goes into 2, 0 times 5 would be 0, then 5 goes into 20, 0.4, so long division, something that we've done before. But if you're using a calculator, all you have to do is 2 divided by 5. Okay? Also, if I wanted to try to decide, if I couldn't remember that the smaller number on the bottom is greater than the bigger number when we're comparing fraction size, then I can actually do 1 divided by 3 is 0.333. Compare that to 1 divided by 6 is 0.166666. Right? So I know that 1/3 is greater than 1/6. Okay? If I want to change it to a fraction, remember how we talked about how you would say 4 and 3/10, okay? Or 4/10 would be 0.4. So vice versa, the way you say it is the way you write it down. So I have 0.4, so if I was gonna read that, I would say 4/10. So that's what I would write down, 4/10. Okay, that's my start, and then reduce it to 2/5. 65 over, 0.65 is read as 65/100, right? So all I have to do is put 65 over 100, because that's 65/100. That's the decimal fraction. And then I can reduce that to 13 over 20. So that's how you make a decimal a fraction. Okay, so let's just talk about that a little bit. When adding fractions, decimals, what if I told you 0.4 plus 0.44 plus 0.444? How would I add that if I didn't have a calculator? I would line up the decimal places, right? I heard a lot of whispering, a lot of whispering. So 0.44 plus 0.444. Then what can I do for math purposes only? Okay, add some zeros so that they all line up. Go down 4, 8, 12. So 1.284 would be my answer. Okay, what if I said, I need to put, this is in mLs per hour, and I need to put that in an IV pump. What do I need to round to? The tenths, or how many decimal places? Right? So, right, somebody said, so if this is the one I want, that was the worst square ever, more trapezoidal. Anyways, that's what I want to round to, so I'm going to look at this one here, the next one over, which is 8, which is greater than 5, right? So then I would round this one to 3, right? Get rid of that business, okay? So 1.3 would be the answer, if I told you to round to the tenths. Make sure that you look to what I tell you to round to. Like when we get to temperature, temperature's always rounded to the tenths, okay? Weight, most of the time weight will be always rounded to the tenths. There'll be some medication doses though, that we round all the way up to the 1,000, which is 3. So make sure you understand when I tell you round to the thousands, round to the hundreds, round to the tenths, what that actually means, okay? Questions so far? We're just cranking right through, okay? This should be pretty much review though. Ratio and proportion. So we